Okay, so this is the first page of tangents to circles. The first directions ask us to determine if line AB is tangent to the circle. So line AB is this red line, and it forms a triangle here with these other two lines, segments. And if it is tangent, we go back to our definition of tangent, and we say, look, if it's tangent, it should only cross the circle at one point. And it's going to be perpendicular to a radius. So we go back to our idea of what perpendicular means. Perpendicular means it should have a right angle. So that should be a right angle right there. So we got a question, is this a right angle? Can we even find out if it's a right angle? We go back to earlier in the year, and those of you in my class probably remember me giving the dumb story about Goldilocks. And it's too hot, too cold, or just right, right? It was either too big, so we either had the hypotenuse was too big, and that was equal to obtuse. And then we had the hypotenuse was too small, and that was acute. And finally, we had the hypotenuse was just right, and that would be a right triangle. Okay, so a obtuse triangle, acute triangle, right triangle. But how did we know if the hypotenuse was too big? We had to use a certain theorem that we all know very well. What is that theorem? Ooh, Pythagoras. All right. So we need to check this. If this works and they are equal, then it will be just right. If it's anything else, I really don't care in this problem whether it's obtuse or acute. If it's not equal, either one of these is going to be not a right triangle. So let's try it out. First off, we need to make sure we identify A, B, and C. So A we can call 16. How much is B?
20.
So is B the green side here? Would that be A, B, or C?
C.
Yeah, because that's the longest side. So that would be C, which is equal to 20. And y'all that are watching can see my freaking out board, and, well, we'll have to deal with it. Let's see. See if I can come back. All right. So C is 20, and then how much is B, though? Was B given? Could we imply it from something?
Oh, yeah. 12.
Why is it 12?
The radius.
Yeah, because this radius here was 12. So that means that this has to also be 12. And more of my Pythagorean theorem is disappearing as we speak. So I got 16 squared plus B down here is 12 squared equals C, which we said was 20 squared. And we need to plug in and see if this is going to work. It will work. We're going to get 256 plus 144 equals 400. And 256 plus 154 or 144 is 400. That's equal to 400. So, yes, it is a right triangle. And if any teacher or somebody who knows their math is looking on, it is also not a right triangle. No, the triangle is a right triangle. The problem is this is not a situation that could actually exist in a circle. Somebody came up with numbers here that don't work. And we could show that by doing ow. Outside times whole equals outside times whole. 16 squared here on this side is not going to be equal to 8 times 20. Outside is 8, 20 is the whole. Those are not going to be equal. So really, this line is not a tangent, even though it shows that it's a right triangle. The problem is one of these vertex is not really at the center of the circle. Okay.
So, yes, that's right. Triangle.
Okay, so the other three were the same as the first one. You need to use Pythagoras theorem to find out if it was a right triangle. Number 5 is the same thing, but they are telling us that it is tangent. So we know that it is going to be meeting at a right angle here. And since that's true, then all we need to do to find the segment length is use Pythagoras theorem, where I've got A, B, and C. And so that's going to be 4 squared plus our unknown B squared equals 8.5 squared. So B squared equals, what's 8.5 squared? So around 70. 72.25 minus 16. So B equals the square root of 50, is that 56.25? Okay. And what's the square root of 56.25? 7.5. And was that rounded? It was exact? Okay. 7.5. All right. Yeah, the other three are going to be the same. Use Pythagoras theorem to find the third side here, here, and on this one, don't forget you already know the radius, so that's going to play into one of the sides. And number 7, yep, they're all going to be the same. So moving to the back. How are these different? Well, this plays to a different portion of our notes today. In our notes today, we showed that if we have two tangents, this is a tangent intersecting another tangent. So if this is A and B, what do we know about A and B? They are the same. According to our notes today, we did ow, and we found that A times A equals B times B, which is A squared equals B squared. We take the square root of both those sides, and since it's linked, we don't have to worry about the negative cases, so it's just A equals B. And that tells me that this blue section here is going to be the same for both of them. The red sections are going to be the same, and the green sections are also going to be the same. So what can I copy over? What do I already know? I know that 11.2 is on this red side, so it's also going to be here. I know that 10.5 on the green one is also going to be there. Can I find the blue one given what we know? Sure we can. How long is it? The blue line here. How long is this section? Nope. It doesn't have to be the same as the red one. But together, what do they add to be?
12.
Let's call this x. What does x and 11.2 add to be?
22.
Yes. Sum of parts, right? Sum of parts. So part plus part equals whole. So I can say 11.2 plus x equals 23.2. Subtract 11.2 from each side, and I'm going to get x equals 12. Can we find the perimeter of the polygon? Is the circle a polygon? Is a circle a polygon?
No.
No. So they've told us which one it is. They want the perimeter of the triangle. Circles are not polygon because they have curves. We only want straight lines for polygons. So this is going to be add all these together and see what you get. So I'm going to get 10.5 times 2 plus 12 times 2 plus 11.2 times 2 should equal my perimeter. And what'd you say it was? 67.4. Anybody disagree with that? Let's see. This is 21 plus 24 plus 22.4. That sounds about right. Okay. I'm going to pause this and give a chance for you guys to work some. Okay, we're back here for number 10. So let's highlight the ones that are going to be the same. If two tangents intersect outside, then they should be the same. So these two red ones should be the same. And this green one, these two green ones should be the same. These two blue ones should be the same. And just because I've ran out of colors, I'm going to go with red again. These two red ones are the same as each other, but they're not going to be the same as the top two ones. Okay? There you go. Just so we don't have any just issues with it. Oh, and my green ones decided to disappear. Okay, so now we need to translate whatever information we can. Do we have any measurements that we already know? Well, I don't know this red double one down here, and I don't know the blue one at all. But I do know the green ones, right? The green one on one side is 4.6, so on the other side it's going to be 4.6. Let's do this in black. The red one is 13, so over here it'll be 13. And that's going to be this distance. So the question is, how much is this other distance here? Okay, so it's going to be 25 total minus this 13. So this is 25 minus 13 would give me the 12 that is this side right here. And if this is 12, then this side is 12. And how would I find, that's this side right here is 12. How would I find this missing piece? Well, I'm going to do 21.8 minus 12. And I believe that's going to be 9.8. Somebody should check my math. And then this will be 9.8. And add all of those things together to get the perimeter. So I'm going to get 13 plus 4.6 plus 9.8 plus 12, but there's 2 of all of those, so I'll just do P equals 2 of that. Add that together, tell me what you get for your perimeter. Let's see, I got 25, 4.4 plus 10, so 14.4 times, let's see, 25 plus 14.4 is going to be 35, 39.4 times 2. is going to be 79.8. Is that right? 78.8. $78.8. There we go. Okay, and let's examine how the rest of these look. I'm going to clear this. Oh, better do my... number 12, same as the previous ones. Number 11, same thing. We're good. Okay, so number 13. Find the angle measure indicated. Interesting. Okay, so let's start with number 13 here. This goes back to angles. And a couple things we know. If this is tangent, then this is a 90-degree angle. That's a 90-degree angle there. This is 63 degrees in here. Okay. These two are radii, which means they're the same measure, which if I go back to what a isosceles triangle is, we know that the base angles theorem tells us that these two are the same. So that's 63 and 63. Add those together. What's that going to be? 126. Subtract that from 180, and I'm going to get that this is going to be 54 degrees in this corner. If that's 54, and this entire angle was a 90-degree angle, then the other angle here had to be 90 minus 54, which is, what's that going to be? I believe 36 degrees. And we're done. Not even a whole lot of hard work in this one. Okay, I'm going to pause it for a minute. Okay, this is the last problem I'm going to do, and all these pages were due on Friday 4/12, except for the very next page that we haven't covered at all. So we're just going to have a check on these tomorrow. Now, number 16, I have to go back and look at this idea of the radii. So we've got radius, 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 radius. Those have to be the same. And I know that this is tangent, so that means that this is a 90-degree angle. And so I can use the fact that this is a right triangle, and I already know two angles, 90 and 52, to find this angle here is going to be 180 equals 90 plus 52 plus x, and solve it, and I'm going to get x is equal to 38. Check my math behind me there. And if this is 38, then the other one, since this is an isosceles right here and here, then this angle also has to be 38 degrees. Okay? And since I have those, I can use the triangle sum theorem again to find this angle. 180 equals 38 plus 38 plus, we'll call it theta this time. And that's going to be, let's see, 180 minus 60, 76, so 104 maybe? So this is 104 degrees. I might have been wrong on my calculations. Good? All right. Are you ready to have it tomorrow?